Hello, I'm Karen Coyle. I'll be your first presenter. A couple of sort of administrative things. I want you to know that we're recording this and that it should go up on the Dublin Core YouTube channel. Also, as we go along, if you have questions, please put your questions in the chat. Partly so you don't forget them, but also so we have a record of them. And then we'll get to questions in a bit. Do remember to mute yourself whenever you aren't speaking. So I thank you for coming to this presentation that we're going to do, this meeting on the Dublin Core Tabular Application Profile. I want especially to point you to the GitHub repo, which is where we put all of our documents and where we'll also put this presentation and anything else that relates to the application profile, to the TAP. The agenda for today is that I'm going to run through basically a short explanation of what it is that we have developed so far for the TAP, and including what we haven't yet developed or what we still need to do. After that, we'll have questions and answers, which is why we'd like to have your questions in the chat. And then Tom Baker is going to talk about some interesting programming that's going on that uses the TAP to go from TAP to other formats, and also directly to validation schemas. So I think you'll be interested in that. So let's get started. First, I want to say this has been the Dublin Core Metadata Initiative Application Profiles Working Group work. And we've been doing this for over a year. A number of people have contributed. I wanted especially to do a shout out to these folks who have done a lot of work to make this possible. So thank you very much. So let's start by talking about what we mean by a profile. Dublin Core has been working on this idea of profile for a long time, given that the Dublin Core terms are intended to be very reusable, and yet they have a sort of a minimum definition. So the idea being that you reuse these terms in a profile. Therefore, profile defines your metadata practice and also the constraints that you have put on terms and properties and values. And it's a reuse. In the Dublin Core sense, it's always a reuse of vocabulary terms that have always been previously defined. There's a lot of uses for a profile. It can document a community practice, and our intention is that it works both for humans and machines. It can be input to data creation forms. We really want this one to be able to translate to data validation methods, which is a key use of a profile. And it can help people manage ingest from data stores, either their own or someone else's. In particular, with the TAP, we had certain functionality in mind. We wanted to define a metadata structure, a simple metadata structure for application profiles. We wanted to define constraints, the most common constraints like cardinality and data type and value constraints. We wanted the application profile to be readable, and therefore we've included labels and notes. And I should tell you that as we were working on this, we decided that the most sort of efficient way for us to come up with something usable was to pick a type of metadata that we were aiming at. And so we designed this with RDF metadata in mind. Now we have a meta problem here, because already I believe I found myself mixing up some things that may have confused you. So there are really three different things, three different levels that we address. The first is a vocabulary and structure for a profile. The next is a profile that describes your metadata and its constraints. And then beyond that, there is the instance data that conforms to the profile that you've created. So the TAP is this. It is just the vocabulary and structure for a profile. However, as I go through these slides, because otherwise that would be very abstract, most of my examples will include sort of sample metadata. No, excuse me. See, there I go confusing it. Sample profile data that you could use to describe some metadata. And we're not going to show instance data and how it conforms to instance data. That maybe we can do that at another time, but that got to be too complex. So the application profile, the tabular application profile, has only 12 elements. Very simple, and yet we think quite powerful. We decided on a tabular format, and in the tabular format, only this upper level is what is the TAP. The TAP defines the columns that would be in a tabular format. Now, why a tabular format? We looked at what people are already doing with application profiles. And what we discovered, although in a sense we kind of knew this, but what we confirmed for ourselves is that many people are using documents for their application profiles. And in those documents, they make use of tables to give their lists of data elements and constraints. And other folks are actually using spreadsheets. And these seem to be the way that people are thinking about the structure of their data. So we decided to go with this. It's very simple. It has, of course, obviously some limitations, but this is what we felt would be a good basis for a simple application profile. I'm going to walk through what you might want to do with the TAP. And I want to say that it is, most of what is in the TAP is optional. You use what you need. The only thing that is required is that you at least list a property. And this is the TAP data element is the property ID. You could create an entire profile just with a list of properties. And might not be terribly useful, but that would be actually a valid TAP. Most likely you're going to want to add a data type. So we have the value data type column. You can also add labels and notes to make it more readable, because we assume that humans will create these, and that there will be times when humans want to read these to understand what the definitions and rules are for your metadata. Another very common need is to say whether things are mandatory or repeatable. So we have cardinality. We have 2 columns. They are Boolean, yes or no. And then we have something that we call shapes. Those are for the things that you describe, that you wish to describe in your metadata. And let me explain a bit about what these are. A shape is a group of statement constraints, I'll get to that soon, that share a node, a subject node in RDF. And they must be identified with a shape ID. So here we have presumably a very simple profile that has two shapes, books and person. The property ID and all of the constraints in the remainder of the table are we've been calling a statement constraint. And this was part of our effort to not confuse between this TAP level, which is that level 1 that I showed you, and the actual application profile or the instance data. So we've developed some definitions of terms to try to help us keep those straight. So a statement constraint is the property and all of the rules that relate to the property. And a group of statement constraints can be gathered together into a shape. And I think that most of you will, will have in your head the idea that you have entities and descriptions of entities. And this parallels that, just using some slightly different terminology. So here we have a very simple profile with a book shape and a person shape. So it has two different shapes. And the way that those connect to each other is through this element called value shape. And the value shape and the shape ID must be identical strings. They could be URIs, they could be whatever you want, but they must be identical. And that will connect together the different shapes. So I think that you can see, if you think in terms of RDF, how this becomes a graph with a value, with a URI value that then is the subject of another graph. And again, if any of this is confusing or you have any questions, pop them into chat. We'll come back to anything that you need to come back to. Because we had in mind, in particular, RDF, we came across some sort of interesting gotchas in terms of data types. And that is that RDF has nodes and it has data types. The data types are only literal data types. And they're based on the XML schema data types, plus I think 2 that RDF adds in. And then RDF has node types, which is literal IRI B node. We thought of using a single column for these. We decided that we weren't sure that that would work well, that it kind of, we would be sort of polluting the value, in mixing the two together, which we didn't want to do. So we have 2 columns, one for the node type, if you desire that, if you need that, and one for the data type, which is limited to literal data types. Then we come to value constraints, which are a bit both necessary and an area where we haven't yet concluded how we're going to handle this. So a value constraint, you may want to say that your subject is a string, but you may want to say more than just that it's a string. You may have more constraints than that. And what we have created so far is a value constraint column. This value constraint column has turned out to be very useful for, if you're thinking in terms of RDF, for assigning the class for an RDF type. Right now, what we have so far, and I'll get to that in a moment, is that the value constraint can be a single string or an IRI. So if you want to say the subject is always history, that the string history, you can put that in value constraint. I think you can see the limitations of this. So here's our our dilemma. Our dilemma is that in order to have interesting value constraints, like this is a URI stem, or this is a number with a minimum and a maximum, or this is a pick list, that that just putting those values into the value constraint column would not be clear. And so we need to be able to say what kind of constraint it is. So we're looking at this point, and we want your help on this to help us fill this out, to define a relatively small number of highly useful constraint types so that people can do the kind of constraining that they need to. And you can just imagine that, that you want to say that, these are school children, they, can't be less than 6 years old or more than 18 years old, all of that type of thing that you do with your data. So we'd love to gather from you examples of what you need and to see if we can fit that into this, this duo here of value constraints and value constraint types. And we know we won't be able to do everything, the more complex things, but we're heading for the 80 to 90% rule. There's a number of other things that we haven't resolved yet, and and many of these I have created issues for in the GitHub repo. So if you can go to our GitHub repo, and these are the issues with the issue numbers. You saw that in the examples, I use namespaces like XSD colon. Well, if you're going to use a namespace prefix, you need to somewhere say what the full namespace is, what that prefix expands to. We tried to put that in the table. We couldn't figure out a way to do it that didn't reuse columns in a way that we weren't comfortable with. And so at this point, we're assuming, but we haven't defined, that that should go into a separate file. Now, what is going to be that separate file? What structure is it going to have? Where is it going to live? How is it going to be connected to the table? That's what we're still working on. If you've looked at the work called CSV on the web, they have a data file that goes with a CSV file that is pretty complex, but it would also allow us to include administrative information. You could, give alternate column names, because we realize that those column names are not very friendly. So that's issue number 3, if you want to make comments on that. So the other thing is how to handle multiple values in a table cell. Oftentimes we want to say, this or that. And we haven't figured out how to do that fits in well with the CSV standard, so that programs or modules which exist in many programming languages to pull in standard CSV would be able to read this. We obviously, because we're talking about comma separated values, commas aren't going to work. And yes, and quotes. Everyone hates having to program around quotes. The CSV definition, which I've given here, it's an IETF document. The CSV definition states that everything in the cells are strings by definition. So you shouldn't need quotes, but will we need quotes if we want to do other things with our strings? Another unresolved issue, but one that we really care about, is internationalizing. We want to make it possible to internationalize the table and its contents. And again, this is where having a separate file that carries information could be very helpful. And there's other ideas having to do with adding internationalizing information in the actual vocabulary definition. Boolean values, the definition of Boolean values, and I've made this issue number 7, the official definition of X in the XML schema is that Boolean values are either true, false, or 1 and 0. This might be sufficient, but you'll notice that I've always used Y and N for yes and no. Should we define a limited set of values that are part of this standard TAP, should we allow people to use whatever values they want? And again, a lot of this is a question that has to do with interoperability. In thinking about RDF, we started thinking about open and closed, whether or not the profile is open and closed. And I believe that this is valid even outside of RDF. So open would mean that other properties and shapes are allowed. Closed means, only what's in the template. That's my application profile. I don't want anything else. And then the question is at what level? Do we do this at the shape level, the profile level? So I've created issue number 8 for that. And I would love to hear both what you think and also hear about what you're already doing if you're using profiles of any kind or just, in your metadata. There were a couple of things that we've considered out of scope, for the moment, at least. Some of them have to do with the limitations of us having chosen a tabular format. We have a difficulty with any interaction between properties or shapes, the and, or, and not. When you have a tabular format, it's very hard to refer back to another one and say, it's this one or that one. We have some ideas as to how we might do a few simple functions of this nature, but that's going to be a limitation. So the application profiles or metadata that has a lot of that kind of structural questioning may not be able to, to fit it all into our tabular design. And we realize that there are limitations. We also haven't addressed tabular designs that require multiple spreadsheets or multiple tables and how we would link multiple tables together. And we know that there's an interest in, and many people do create multiple tables in describing their data. So that's something that for the moment we aren't addressing, but we're at the beginning and we're hoping to see how we can enhance or expand what we've done. So I want to give you some resources. We really do want people to give us information, to participate, tell us what does and doesn't work. So again, our GitHub repository is the place to go. We have created some examples. They're made up examples for the most part, but we do have some examples in the GitHub repo. We would like to have many more. We would like to have more examples, both of profiles and data that we can play with as a way of sort of testing out what we've done. A greater variety would help us move this forward. So you can participate by on GitHub with issues. You can join the mailing list, and if you go to the opening GitHub repo screen, you'll see at the bottom how to join the mailing list. It's not a high high activity But we do some amount of discussion there. We would love you to offer data that you have that we could profile, and offer profiles or metadata descriptions that we can try to tap. So at this point, I would like to see if there are questions that have come in that we can address. Tom?
No, not yet.
Okay.
Oh, wait, one question coming in.
Okay, good. Yeah. Send your questions in, please.
Yes, go ahead and type it, or I can unmute. I can ask. I'm asking you to unmute so you can ask your question.
Okay. Hello, this is
Hi.
Anna Baptista talking. Hello, Karen. Hello, Tom. Hello, everybody. Thank you. This work is very, very interesting. This work is very interesting. I want to make a question regarding cardinality. So you have here one column for mandatory and one column for repeatable. I am assuming that this is related to properties. I mean, for instance, one book may have several authors, so I would put this property as repeatable. But in my experience, I would need another kind of cardinality that is for values. For instance, I want to be able to say that I want to encode the address in two ways, either using a string or not either. I want to do cumulative ways. So I want to put an address as a string and as a geographical coordinate. So I am repeating the property, but this is for the same thing. It's not for different things, like in the author that you put different properties for different authors. You repeat the creator to say that it's another author. Is there a way, did you think about this, or are you thinking about including this kind of cardinality for values, not for properties? Yeah.
We haven't included that. It may be possible to do it by repeating the repeating the property with a different value type. And it would be great if you could send us an example and we'll try to mock that up. However, okay, one of the things that we haven't managed to do is, so for example, I think I have this, I may have put this in one of the GitHub issues, which is if you have, for example, your creator and you want it to be either a string or an IRI, and then the string would have certain constraints, or the IRI would have certain constraints. And this is the kind of either or that doesn't fit well into a tabular format. So we'd like to see more examples of that to see if there is a way to provide them. But in general, some of these more and or not type type constraints may not fit in, but we don't have enough examples to try it out. So please send us any examples. Other questions? So I have a few other things that we could talk about, and while you think about, I mean, I can't tell if we've sort of killed everybody with this, and you're all sitting there with.
I'm sorry, Karen, I was muted. I was telling you that we have questions coming in. So
Oh, good. Oh, good.
yeah,
Okay.
I wanted to first call on Phil, who wanted to respond to Anna.
Oh, good.
Yeah, sorry, I was just wanting to respond to say that I have done what you described in some examples as a solution to the issue that Annalise raised. That is, I've repeated statement constraints for the same property to say, yes, you can have author as either a shape which conforms to person or just as a text string, which would presumably be the name. It's quite useful, for example, if you want to say that if you want to use the RDFS type mechanism to say that this must be a book, but optionally you can say that it's also an ebook or something like that, or it must be a book and it must be a learning resource is the one that I've used in examples. But yes, you're right in saying that it can lead to difficulties if you want it to be, if you want to say that it must be one or the other. There's currently no mechanism for doing that, and doing that is probably out of scope.
Yeah, so we also have a question saying about cardinality and restrictions, combining the two of them, cardinality and restrictions. Can you say that you accept many but not more than 5, 10, or n? For example, you accept multiple mail addresses but no more than 3 or at least 2?
I'm hoping we can fit that into the value type, that not the, I mean the value data. No, sorry, I'm getting, sorry, here we go.
Value constraint type.
Value constraint type. Yeah, sorry, the word wasn't coming to me because I'm sitting here looking at my screen. I'm hoping we can fit it into the value constraint type, but I'm not sure. We haven't tried it yet.
We have a question asking how we envision use that TAP will be used by the community.
Well, what I'm hoping is that many people will find that their own profiles fit this format, and that means that you can borrow each other's profiles. If you want to read somebody else's data, you can use their profile to help you understand the data. Also, if you're ingesting someone else's data, this can help you validate that data as you ingest it, because as we know, we often find that data is not quite, it doesn't quite meet up to what we thought it would be. So those are what I'm seeing as being some of the uses. Others of you, do you see, Tom, Phil, Ben, other?
If I can jump in, what one thing that I think is quite useful about this is, developing the application profile in a tabular format as for essentially as a CSV means that you can use tools like Google Docs, Google Sheets to create the application profile, and you can, that's a very easy format for sharing between a community to get comments on and for multiple people to work on and have their input, and then you can export it as a CSV and start doing things like generating checks from it.
Right.
Okay, so do we want to, we have a number of questions here. We're getting some positive feedback about differentiating between value node type and value data type. and putting the value shape into a separate column. And we have a question here. How do you handle rules about transcribed versus controlled versus uncontrolled?
So controlled would end up being in a value constraint type. In other words, if it's controlled, you would be probably saying that you probably would be giving a URI stem that points to the list that you're taking values from. Uncontrolled would simply be a string. And the other one was, there were three.
Transcribed.
Oh, transcribed. At best you would be able to put that in a note, but that isn't a value. And also, I mean, that isn't a column here, but also there really is no way to check that. That's instructions for the human, but there's no way for a machine to check that.
Okay, we have a question here. Does this person shape imply an object, not a string? I should say that I think I will be briefly addressing that point in my brief presentation after this Q&A. But yeah, Karen.
Yeah, shapes are objects, not strings. If it were a string, then you would have the value data type of string. Now, we know that RDF, the W3C is looking at allowing strings as subjects, which could change this, but this shape ID, however, can be anything. I mean, it could be, as you see here, person. The shape ID could be, if you have a URI for that thing, it could also be a URI.
Will we have a vocabulary to express the application profiles using RDF?
Okay, so that was actually my next slide, which is how should it be formalized as a vocabulary? So we haven't decided this. I personally think it should be formalized as a vocabulary. If it were formalized as an RDF vocabulary, would that be useful for even for folks not using, not familiar with RDF? Tom, I don't know if those who were working on actual code have a particular interest one way or the other. It does seem to me that we're going to want IRIs for the terms, and RDF may help us with internationalization because it would allow us to at least add multiple language labels for the terms, so that these sort of unattractive terms that we've shown you here don't have to be the ones that people see.
Okay, we have another question. Are there any archives or museums workers on this call or in the community, as we use DC and metadata quite differently often?
I don't know. Are there folks who, Ben and John, do you do archives?
Well, I think that, I mean, the general, we want to encourage people to view this format as it is modeled on RDF data, but I don't think that its usefulness is limited to RDF. And it would be helpful to have some more input from people who are interested in using the format, the model with data that's not RDF. That would be
right.
Very interesting.
Yeah, I would love to see if you have data, if you have descriptions of your data, whether it's just a document or if you've already done things like tables. It would be great to see that. I did look at profiles done with Content DM. However, those were very simple and you didn't conflict as far as I can tell with what we have here. So it would be great to get more input from archives.
Okay, can you specify that a value comes from a list of controlled vocabularies? I'm thinking of the long list of controlled vocabularies from Library of Congress that are allowed in subject headings.
Right, that's what we're wanting to do by having a value constraint type of URI stem. And then you could basically put the ID loc.gov/subject there, and that would mean any value from this list.
Could allowed values be a list of shapes, such as a list of values? Yes, no, maybe?
I'm not quite, my brain isn't getting that one. Could allow.
Well, I think list of shapes is we call it a pick list. We've been referring to that as a literal pick list, and yes, that's one of the constraint types that we want to support.
I think though also there's the question of, could you say that like an author, let's look at what we have here on the screen, that that your DCT creator, which is an author, could be either person or something else, or schema.org something, or whatever, or FOF something. In other words, could you have an or there? And again, that's where we have our problem with multiple values in a cell. So that's something that, that we're aware of, that we need to do. And there is a, let me see if I can go back and find it. It's issue number 4. So if you have examples or want to comment on that, please go to our GitHub and issue number 4.
Okay, how do you specify mandatory if applicable? I'm thinking of series information for a book.
Yeah, again, that's a value that cannot be tested. So that could go in a note. It's for a human, but a machine can't determine whether it was applicable. So I would see that as a note.
Okay, so I don't see any other questions. Do we want to try to finish the main part of this by the top of the hour? We do have the option of running over if anybody wants to stay on and chat. But just noting that it's 1:45 right now.
It's 1:45. Let me just show very briefly some of the issues that I would like people to respond to. Number 6 is one. Number 8, whether or not things should be open or closed. I'd like to know how you already view your data in this way. And the question about Boolean values, there's other issues there that are a bit more complex, but I really do want you to go there, and it doesn't matter. Don't think that you have to have a well thought out formulation of your question or your comment. We really just want to hear from you. So now at this point, Tom, I think we can turn it over to you.
Okay.
Are you ready? Okay, I will stop sharing.
And
there we go.
Okay, this will stop. Okay. You should see a PowerPoint.
Not yet.
Not yet? Oh no, I have to.
Try a different screen.
I have to.
There we go.
Okay, do you see the PowerPoint?
Yeah.
Okay, let me try to do presentation view here. Is that better?
No, we aren't seeing presentation yet.
Oh.
go to the very left and click presentation.
You're not seeing it?
I'm not. Is anyone else?
I was afraid of this. Um,
That's okay.
We
sorry.
saw your PowerPoint just
And then
with
it disappeared.
yeah, and just with the thumbnails down the side. That would work if you can't
Okay.
get it into presentation
Yeah.
mode.
Okay. I'm not going to forget the thumbnails. I'm going to do it with the thumbnails. Can you see it now?
Mhm.
Okay. Okay. So I'd like to tell you briefly about our software project. So, oops, how do I advance this? Okay, so I think you've all seen one of these. It's an RDF graph. We also call it instance data. And this one happens to be very similar to the example that Karen showed. And as we see it, an RDF graph or instance data is composed of both entities, in this case, a book and an author, and of statements about those entities. So the book has a title, Moby Dick, a publication date, and an author represented here by a node. An application profile looks at data in a generic way. So the graph of an entity plus the statements about that entity is referenced with a shape. Let's call this the book shape. The statements about a book are viewed in terms of abstract constraints. So the statement constraint says that this statement constraint says that the statement in the data must use the title property with a literal value, and that the statement is mandatory but not repeatable. This statement says this statement constraint says that the data must have a statement using the DC date with a value that conforms to the XML schema data type for year. And this statement constraint says that the data must have a statement using DC creator with an object that conforms to the person shape. So moving over to the person shape, we see that the data must have a statement using FOF name with a literal value. With an application profile, we can examine the instance data and compare it against the abstract shapes with their statement constraints to see if the data conforms. In the DC Tabular Application Profile, we define components that are commonly used for specifying shapes and shape constraints as columns in a spreadsheet. And we're working now on developing a Python modules and command line tool for parsing CSV files according to the Tabular Application Profile format. This tool can inspect the contents of a CSV and perform some basic consistency checks. And it can also translate the CSV into shape expressions language, also known as SHEX, in order to validate instance data according to the application profile. So we will soon be adding a subcommand to translate the CSV into the SHEX compact syntax, which is easier to read and to edit than JSON. So you could use the DCTAP model and format as a way, as kind of an on-ramp, as a way to generate a basic SHEX schema, and then if you had more complex requirements, you could take it from there. We would also like to add a subcommand to validate instance data using SHEX directly without needing to first generate a SHEX schema. This is work in progress. We're making good progress, but it does not yet support all of the features that we want it to support, just well as the DC TAP model itself is work in progress. But if you are interested, I welcome you to please get in touch, create an issue on the GitHub repository for the command line tool, or give us feedback. Are there any questions? That's it. Can you hear me? Hello?
Mhm.
Yes.
Yeah, so that was, I'm done. Oh, I should be looking for questions. I'm sorry.
Well, I'm looking at questions. Don't see any. Do anyone have questions for Tom about the software? I think that showing that we can move from the tabular format to something that is probably more ingestible, or can fit into anybody's software, as well as going directly from the tabular format to validation, which I think is really the key thing that that we're aiming at. And of course, we've had validation in mind the whole time we've been working on on developing the format.
So I'd just like to comment. I think that part of the motivation for me was to provide a a spreadsheet is pretty easy to use, and it can be difficult to learn the syntax of more powerful validation languages like Chex, but at the same time, I think that a spreadsheet model itself has a specific meaning in a validation sense, um, only to the extent that it's backed up by a real validation language, because we're not actually building a validation language. We would rely on Chex or Shackle or some other language to actually take the data in a TAP CSV and interpret it for purposes of validation. But I think I see it as a good way to get started, and um, just just one closing thought is in our discussions in the working group for developing the TAP model. I think there's always a bit of back and forth about how ambitious we should be about getting the spreadsheet to support different types of distinctions, and I'm personally sort of fall on the side of saying that that we shouldn't get too fancy with a spreadsheet format. We should keep it easy to use for very basic use cases, that if people really want to do more complex things involving and or, that it would make sense to learn a validation language like Chex, and which does support it. But these are all issues that are are under discussion, and we really are happy to have this opportunity to kind of reach out and get more people involved in that discussion. So we really welcome your input on this.
Okay, anything else? Well, we do hope to hear more from all of you in the future, hope maybe the near future, but we're going into the holidays. But please know that we really do want to hear your comments. We welcome participation. We would love to get examples of data. You can send us data and say, well, can you do this one? All of that will help us very much move this forward. And hopefully within a relatively short period of time, we'll resolve some of the outstanding issues, and then we'll be able to declare that we have something that is at least beta, whereas today it feels a bit alpha. Tom, any other thing before we close?
No, just that we're getting really nice comments in the comment channel here. So getting lots of murmurs of approval, basically, about the direction that this is, and a vote to a ++ to keep it simple. Yeah, this is all very helpful, and we look forward to hearing from you. Either drop us a line, or go to the GitHub issue tracker and open an issue, or yeah, get in touch.
Okay, great. Well, thank you. Thank you for attending. It's been great. And we'll try to keep you all informed as we move on.
Karen, do you want to close now, or do you want to stay on and informally
Unless people
chat?
have other questions, it looks like people are ready to go.
Yeah, it
So
looks
we'll
like
go
it.
ahead and close this down. And boy, we really appreciate your comments, because it's been yeah, it's very good to hear that people think this is interesting. Okay.
Thank you all for attending. Thank you.